So thank you all for taking time from your busy day to join our presentation, Gateway Router, the Swiss Army Knife for Radiology. Let me introduce today's presenters. I'm Al Kappel, Director of Sales at RamSoft. With us today is Greg Smith. He's one of our regional sales manager, and Greg has a long history in healthcare. Also with us today is Shreyas Ganapathy. Shreyas is a product manager with RamSoft and has an extensive technology background. So a little bit about who RamSoft is. So we were founded over 25 years ago, and we're a patient care company, not just a software company. And this ideology guides the way we envision, develop, and deliver solutions to our customers. And with that in mind, we develop software that is single platform, very easy to use, and at the core of our platform is our DICOM routing engine, which you're going to learn more about today. So, some highlights of today's presentation. So today we'll review some typical healthcare connectivity challenges, discuss how Gateway DICOM Router acts as your Swiss Army knife for radiology, review some of the benefits of our DICOM router. There's so many that we can only cover a few in this session. We'll discuss a before and after scenario, and then we'll take questions and provide answers. Keep in mind, if you do have some questions as we proceed along, please go ahead and put those questions inside the questions tab, and we'll answer those toward the end. And then we'll dive right in. I'm going to go ahead and pass it to Greg now.
Thank you, Al, and welcome everyone to our Gateway overview today. And I think this will be beneficial to everyone. The RamSoft Gateway, of course, is a staple at RamSoft and is used throughout the industry by us and other vendors. As you can see here, some basic layouts that we hear a lot about even today. Folks still using CDs to move information, very unsecure, of course, time-consuming, labor-intensive, and overhead to your staff. The second is a typical situation we see a lot of where someone will have another PACS system besides RamSoft. They'll have a gateway in place, and they'll also have a VPN. The challenges here, of course, is that gateway is older. It only moves data. It doesn't prefetch information. It has the ability to only send to one location, and they also have the VPN. So they have a lot of overhead slowing everything down. And of course, if something happens to their connectivity, manually someone's going to have to deal with that. And we'll show you how that becomes a non-issue with the RamSoft Gateway. Again, we have another third-party PACS system. It has the ability to do TLS, but still has to rely on a VPN. You're going to see how we can put a gateway in the cloud and fix this situation and help them make things do a lot quicker. Let me go over quickly what all the Swiss Army knife and what we're going to cover today. As you can see, it's a really simple reason why we call it the Swiss Army knife, because it does so much. The security side, you're going to see how that works and how it can benefit you. Data normalization. This is a huge tool in today's trying to be efficient, get the information correct, because it affects so much in your day-to-day workflow, your billing, your hanging protocols, all the information to deal with, how you can clean that up with the gateway. Custom scripting. That is one of the main tools you're also going to see that you won't see anywhere else. Smart prefetching is beyond just normal fetching, does more and very smart fetching, in which I've seen a lot of people want to see some things done. Automation, you're going to see a lot of that today. Retransmitted protocols. This again, instead of someone have to manually finding out studies didn't go, start pushing studies manually, we can show you how we automate all that very smartly. Multithreading, open up that pathway to get lots of studies going out and lots of studies coming back in over a single pipe. Rules-based routing comes in very, very handy today with a lot of teleradiology out there, and specifically when cases need to go to a certain place, to a certain doctor at a certain time, we'll show you how you can do that. And of course, their gateway is a VNA, Vendor Neutral Archive, and we'll demonstrate that. And Shreyas will do a tremendous job going through all these in detail, very understandable, and also throw in some technology piece. So with that, I'll turn it over to Shreyas.
Thanks, Greg. I'm really excited to talk about all of the things that the Gateway Router can offer. Let's start by discussing a little bit further about the features and functionality the Gateway Router has to offer. And we'll start with security. So imagine a car that is traveling from point A to point B, and while in transit, it gets encapsulated in an armored truck to keep its content secure. The gateway router performs a similar function by taking advantage of DICOM TLS. For those of you who are unfamiliar with DICOM TLS, it's a standard of encryption defined by DICOM to safeguard data from hackers and attacks such as ransomware. Therefore, any imaging data that is transferred from one DICOM entity to another using the DICOM gateway router will be fully encrypted till it reaches its intended destination. So now that we have a good idea of security and an idea of how we can transfer your data securely, let's talk about how the gateway can help with cleansing your data. In other words, data normalization. Here, you're looking at a red car with a yellow door, which seems a bit out of place. This car, on its way to its intended destination, enters a service station and has its error corrected in an automated fashion. The yellow door is replaced with a red one. The service station in this case represents a gateway router. Similar to the example, the RamSoft gateway router supports functions that aid with data normalization. Typically, data inconsistency problems arise when technologists are manually entering information, patient or otherwise, at the time of study acquisition. Our gateway router is available in two offerings, standard and advanced. In the standard version, a few data elements such as facility or organization name, study status can be normalized or corrected when the study is received within the gateway router. And this helps you maintain data consistency in an automated way. So now that we've discussed the normalization functions a standard router can support, let's talk a bit about what you can achieve with an advanced router. Taking the concept a little bit further, let's talk about custom scripting. So what you see here is a sports car on its way to a service center where it will be analyzed and upgraded for better performance. Again, the service center is representative of an advanced gateway router. The advanced router is equipped with tools that allow our customers to script intelligence that can automate analysis and correction of data into the router. Once done, every time the gateway router receives the study, it will execute the rules to clean up data to ensure that data consistency is maintained across the board. So now that we have a brief understanding of custom scripting and its potential, let's take a look at an example. Let me tell you about a problem we solved in the past using custom scripting. A radiology group with over 800 imaging centers had 25 different ways to describe chest B-level reads. And because of this, the center was faced with huge problems in maintaining data consistency across the board. What you see on the right-hand side are the different ways that they use to describe chest B-level reads. And on the left, we have an example of a script that was used to read the study description from the DICOM tags of the study and correct that data. So diving a little bit further into the description, I have a very basic script that is reading the study description from the DICOM tag of the study being received. And what it's doing is it's comparing that description or trying to match it up with the value CXR3VB-read. And so this, I've used the last example in my list of or examples of the 25 different ways to try and show how or illustrate how the custom scripting would work. So every time it reads the study description tag and matches it up with CXR3VB-read, it will automatically cleanse or correct that data by changing that tag to read as chest B level read. So that's a simple script. Of course, this script can be expanded to include all of the examples that has been provided over here. So in short, custom scripting is a pretty handy to automate various functions in terms of data cleansing, giving you several options to correct DICOM data. So having talked about custom scripting, let's extend that concept of scripting a bit to see what else we can achieve with the gateway router. While Al was doing his initial polls, I saw that a fair percentage of people attending this webinar have some problems with pulling relevant priors, for example, and that's where smart prefetch will be really helpful. So person trying to purchase a car is selecting filters to identify specific cars that he or she can view, compare, and purchase. Similar to the example, the gateway router can use the current study as context to fetch the most relevant priors based on any number of defined criteria. The beauty of this tool is that it's extremely sort of flexible in the number of criteria that you can define to match priors. Not only can you use the current study as the context to pull relevant priors, but you can also use scheduled studies or future studies as context to have priors fetched and ready within the system for the radiologist at the time of reading. So essentially, the smart prefetch is an excellent way to fetch and route priors from existing image archives. Having discussed the concept of smart prefetch, let's take a look at another example. So over here, what this script is doing is, again, reading the study description of the current study, and along with the patient context, it's constructing a custom query that's going into the archive and searching for priors which have either chest or CXR or abdomen and within a certain date range. And every time it finds a match based on that custom criteria that we have provided in the query, it will identify that relevant prior and pull it into the gateway router and send it along with the current study to its intended destination. So those are some of the more advanced features the gateway router offers. But what happens when a study fails to transmit? Well, we can automate that as well using the built-in retransit protocols. What we see here is a car trying to cross the bridge, but is unable to do so because the bridge is up. Similarly, there could be multiple reasons a study fails to transmit. Connectivity failure, lack of storage space within the destination DICOM entity, and several other reasons. In case of a failure, the gateway router will continue to attempt to resend the study till it's able to successfully transmit it. However, a question I sometimes get asked is, what happens if a transmit fails? How do I ensure that my other studies reach their destination? And that is where multi-threading comes into play. Here, on the left-hand side, you see traffic moving on a single lane. If a car were to suddenly break down, it would cause a bottleneck holding up all traffic behind the broken down car. Whereas on the right-hand side, you see traffic moving through multiple lanes. Even if one of the lanes were to get blocked, traffic would still continue to move via the other lanes. Multi-threading works in a similar way. Multiple studies can be sent at the same time, even to different destinations. But who controls which study goes where? Well, that can be automated using the rules-based routing functionality. As you can see, the traffic robocop here is directing cars to their respective destinations. The robocop, again here, represents our gateway router. We have the ability to specify routing rules within the gateway router based on multiple criteria, such as referring physician, facility name, application entity title or AE title, and many other criteria. Trigger points for such rules could also be set. You can specify that a study should get routed when it reaches a particular status, for example. That way, whenever a study reaches a trigger point, it will automatically get routed to its intended destination. So those are some of the features within the gateway router, both standard and advanced, that can help you automate your workflows. Having discussed those, let's shift our focus to archiving. Did you know that the gateway router could also be used as a VNA? Here, we see passengers arriving at a stopover destination. And while some of them check into a hotel, others get onto the buses waiting to depart, taking them to their next destination. In this case, the hotel is like our gateway router. In addition to all of the workflow automation features discussed previously, the router supports both conventional DICOM and DICOM web or RESTful DICOM communication standards. And when attached to a storage, it can function as a VNA that can be used for permanent archival of DICOM data, at the same time automating workflows to route images. This VNA can be hosted either locally or on the cloud, depending on the customer's choice. So those are all of the different features that the router supports. What I'd like to do now is go back to the diagram or the picture that Greg showed you at the beginning of the presentation. So we have 3 hospitals here, each of them faced with some unique challenges: secure transport of imaging data, high turnaround time for transfer of images, and challenges with network connectivity, to name a few. So let's see how the gateway router can address these challenges. Let's look at what life after a gateway router looks like. As you can see, in contrast to the previous diagram, all stakeholders are seamlessly connected with the introduction of a RamSoft gateway router. The green icons represent a router, both standard and advanced, and they're automating various functions across the workflow. We've introduced routers at Hospital A, Hospital B, and an additional advanced router on the cloud. So let's zoom into Hospital A to see how the introduction of the gateway router is benefiting them. Previously, Hospital A was using CDs and couriers to transport images between affiliates and study viewers. With the introduction of a gateway router, not only is the hospital able to achieve a significant reduction in the turnaround time for transporting images, they can now leverage rules-based routing to automate the distribution of studies to its intended destinations. They can also make use of basic data normalization capabilities to standardize data elements such as facility name whenever a study is received by the router. And finally, they can take advantage of the built-in DICOM TLS capabilities to securely transfer images from one location to another. Of course, another additional added advantage is that with the introduction of the router, Hospital A now has a local archive of all their studies. Now let's move our focus to Hospital B. In this case, the hospital has a PACS system, but is one that is not DICOM TLS capable. They also have a router, a basic router, but that router has some limitations. First, it only can communicate using proprietary communication methodologies with a PACS that's also developed by the same vendor. And it does not have all of the other advanced automating functions such as rules-based routing, for example, or retransmit protocols. As a result, not only do they have to use a local VPN, but there is still some manual work involved in terms of getting the data to its intended destination. The problem also is that the site-to-site VPNs adds to the IT overhead in terms of procuring and managing all of these VPN connections. It also slows down the transfer speed of data. So aside from all of the benefits that we have previously discussed, such as not having to manage site-to-site VPN connections, for example, introducing a gateway router in the mix can be a virtually instant way to introduce workflow automation and secure communication while dealing with minimal overhead of change management. So having spoken about Hospital B, let's move our focus to Hospital C. Here, the hospital has a third-party PACS that is DICOM TLS capable, but they still have to leverage local VPNs and maintain site-to-site VPNs because maybe the receiving facility does not support DICOM TLS. The other limitations might include that the third-party PACS that has been implemented does not support data cleansing, for example, or does not support multi-threading, for example. And so as a result, there's a lot of manual input in terms of cleansing that data, ensuring that if a study has failed, we clean up the queue and we retransmit manually and so on. There's a fair bit of manual work involved to get the studies to its destination. What we have done here is we have leveraged their existing investment in their third-party PACS and connected it to a gateway router on the cloud. And with that, what they can now do is they can, of course, cleanse their data automatically using custom scripting, and they can use the rules-based routing and various other automation functionalities that the gateway router has to offer in order to automate workflows that they previously could not. So those are different things the gateway router can bring, or benefits the gateway router can bring to Hospital C. I'd like to go back to the bigger picture that we discussed, the life after gateway router diagram, to see what else the gateway router is automating. So as you can see over here, the advanced gateway router, which is hosted on cloud, is connected to an image archive or a VNA. Now, of course, this could be an image archive or a VNA that's hosted on a gateway router or any existing image archive that you currently have. What the advanced gateway router is doing is every time it receives a study, it is using that current study as context to construct a custom query using the smart prefetch functionality to pull the most relevant priors from the image archive and pull that back to the router and send those relevant priors along with the current study to the study affiliates or viewers. Another thing that's happening over here is on the study affiliates and viewers side, if you have a remote radiologist, for example, the gateway router could be repurposed by attaching a viewer to it to become a gateway viewer, that way becoming an easy way to set up an independent workstation for a remote radiologist. As you can see that the gateway router supports bidirectional communication. So not only is it taking studies from hospitals to affiliates and study viewers, but it also has the ability to transport the reports back to those hospitals. And finally, if you are sending images to a RamSoft PACS, we do have another entirely secure, very fast method, proprietary yet extremely secure method of transporting DICOM data between the RamSoft gateway router and RamSoft PACS that we call replication. So those are all of the different automation functionalities and different features that I wanted to talk about. I'm going to hand it back over to Greg now to talk about some of the benefits and the value proposition of the gateway router.
Thank you, Shreyas. You can take a break now. That was quite a presentation, a lot of information there. Great job, though. I hope everyone appreciated all that information and had a good understanding. Let's talk about the value. I think you've already seen the value of what it can bring. With the security piece alone, it makes that one nice piece that you can put in your imaging network to know that all that information is being taken care of the correct way. And reducing logistics overhead, you see many places that the gateway can help your staff there by taking some automation into their workflow they don't have today, making them more efficient. And also, of course, with the low cost and benefits outweigh any cost. And in fact, the standard gateway starts at only $2,499, so it's very inexpensive. Data consistency and reducing errors. You've seen many ways that we do that with structured reporting, with the ability to also cleanse the data and make normalization before it gets released, which is always a problem. We have many gateways sitting in front of other PACS systems, cleaning data before it ever enters. Workflow automation, moving data across when there's failures and making it efficient, and also with the bandwidth that we can help provide with that, with multi-threading. So versatility, I think that's probably the gateway's main name, or should be added to it as the gateway that's versatility. I hope you've got a lot out of this today and really appreciate your time. And I'm going to turn it back over to Al to just do one more quick overview, and then we'll take questions. Thank you.
Thanks, Greg. Thanks, Shreyas. Yeah, very informative. So yeah, we'll just do a quick recap here, and then we'll get to questions. Quickly recapping here, the Gateway DICOM router addresses your challenges with DICOM tag mapping and morphing, of course, routing, data security, storage, and a host of other challenges. Some of the features and benefits include TLS encryption, smart prefetching, routing rules, multi-threading, consistent data, VNA for low-cost storage backup, as we've mentioned. And speaking of VNA, let me also mention that you can store data locally. You can store data also in Microsoft Azure Blob, Google Cloud, custom folders, things like that. And you'll also have the added security and fault tolerance of RESTful DICOM services. So really, RamSoft's Gateway DICOM router is truly your Swiss Army knife for radiology imaging. Great. Well, let's move on to some questions here. Let me see what we have. Oh, here's a good one, actually. Like to know about mobile imaging with the router. Now, Greg, you've done quite a number of mobile imaging solutions, so you know all about this.
The mobile industry and RamSoft Gateway actually is pretty tied together. Believe it or not, one of my biggest mobile practices is a mammography bus project with over 3 buses doing 90 3D mammos a day. They have RamSoft gateways on laptops on all their rigs, and some places they do plug in the networks, but many of them are actually doing it over cellular, commercial cellular, on the buses themselves. We have lots of mobile, one of the largest mobile x-ray company in the United States, doing over 2 million studies a year, runs on RamSoft gateways on each one of their rigs. Lots of this going on today, especially with the standard stuff, mobile MRI and things like that. But the gateway is a perfect fit for this, and it really allows you to do so much out in the field.
Yeah, that it does. Thanks, Greg. All right, another question here is, how long does it take to implement a gateway router? Shreyas, you want to take that one?
Sure. Thanks, Al. I'd like to look at it in 2 different ways. One is, of course, the installation part, and the other is the implementation of the configuration part. And maybe some might argue that implementation is sort of a culmination of both. So installation of Gateway Router is really easy. You can literally download it off our website, and it takes all of 10 minutes to get it installed and up and running. The configuration can be a little trickier based on how you want to configure it and what functionalities you want to implement. But typically, an average implementation of a gateway router gets done in under an hour, assuming about 40 to 45 minutes for configuring the gateway router. It's very fast in terms of plugging it into your existing workflow, and in that short period of time, it can start automating various things that didn't exist previously.
Yeah, very good point, Shreyas. Yeah, and in fact, and I'll direct everybody again, but you can download our 30-day trial to try it out yourself and see how easy it is to do that. You go to www.ramsoft.com. And you can go and request that and download the trial. It's a full trial. It's a full advanced gateway router with multi-threading and scripting, so you can try out all those features. Also, when you get that email, it gives you it attaches a quick start guide to get you through the setup real fast. And people get those things set up very fast, and then really you take it from there and do your own scripting. And there's support available during that trial period, so feel free to reach out to the account manager that would be assigned to that, and they'll get you in touch with somebody to help you out with scripts or any type of routing rules and things like that. So, here's another question. What is the study volume that the router can handle? Well, that's essentially unlimited. Shreyas, you want to answer that too?
Sure. So yeah, I mean, that's a great question, but as Al has already mentioned, the volume that the router can handle is essentially unlimited. The only thing that we do suggest is, while installing the router, the volume still be considered or kept in mind, because we need to ensure that the underlying resources in terms of hardware supporting the router are able to manage the study volume that the router is processing, and also that we have enough storage sized for that router or the machine that's housing the router to ensure that it's able to process all of that study volume. So the router as such can handle unlimited study volumes. It's just the hardware has to be sized appropriately based on expected volumes.
Yeah, great point, Shreyas. And we have platform spec on our website at ramsoft.com to guide you in that. So yeah, I mean, essentially you can install it on a basic PC or laptop. And if your volume is real heavy, most folks that are using it with heavy volume will have a server class, rack mount machine with, all the appropriate resources and RAM and hard drive space and so forth, depending on how they anticipate using it. So another question here is, how many modalities can you connect, and do you need a router per modality? No, you do not need a router per modality, and you can connect as many modalities. It's unlimited. to the gateway router. So say, for instance, it's an imaging center practice. They have 15 different locations, and they're using our PowerServer Cloud PACS, or RIS PACS rather. You'd have a gateway router each one of those centers, and they may have, I don't know, 5 modalities plus at each one of them. So each one of those modalities would send to the gateway router, who would in turn send to the cloud. So, and then as we've mentioned during this presentation, that there are retransmit protocols. So if the internet connection gets broken at some point, the modalities are still sending to the gateway router. Once the service is restored, all of that data goes to the cloud service. So again, unlimited modalities. Let's see what other questions we have here. How many studies can be archived on a router? I mean, that's unlimited. That's really dependent upon the hardware that you put behind it, the server class machine and the storage behind it. And is really your only limitation. I don't know if you have anything else to add to that, Shreyas. But
like we said, I mean, it also depends on the number of studies. So the hardware also sort of has to support the number of studies you want to retain at any given point in time. Some people use the router for storing studies for a temporary purpose. And they'll set like auto purge rules, for example, to purge studies that are more than 3 months old. So they'll only have the last 3 months of data and so on. So it depends on the configuration that the customers want or need. The router is extremely flexible. And like as we've discussed before, and as Al has already beautifully explained, that it's more on the hardware. The limitations lie more on how we size the hardware as opposed to what the router can support itself.
There's a question again on cost. I know we mentioned it, but we'll go ahead and do it again. So our standard gateway router software license is $24.99. We also have other pricing models. We have a subscription model as well. So reach out to us and discuss it further. There's a question about hardware, but we went through that already. Let's see. Oh, here's a good one. Is the RamSoft DICOM router able to use its secure TLS feature to communicate with other vendor DICOM stations that may also support DICOM TLS? That sounds like a good one for Shreyas.
Oh, yes, it is a great question. And the answer is yes, we can. So as long as any DICOM entity is supporting DICOM TLS communication standards, the gateway router will be able to connect to them over TLS and send DICOM and share DICOM data with them. We have no limitations on that. So it's completely, I mean, the only limitation would be if that DICOM entity supports TLS. If the answer to that is yes, we're good to move. And so we support the latest TLS standards as well. So we're also sort of with the market in terms of that.
Yeah, great point. Yeah, and we have many installations out there where we're communicating with other DICOM entities through TLS. So yeah, functions well.
I see a couple of more. There's in configuration part, is it possible to use on-premise server, then cloud server for advanced? Absolutely, yes. It was just as part of the example that we were showing, we put a few standard ones on the hospital side and an advanced on the cloud, trying to show the different sort of workflows that you can automate and functionalities. But having said that, absolutely, an advanced gateway router can also be set up on an on-premise server. There should be no problem with that.
Yeah, exactly. Got a lot of installations either way.
Yep. Another question is, can this be behind an existing firewall or does it need to be on the outside? Well, it depends. I mean, all of our installations are behind existing firewalls. I mean, we take security extremely seriously, also threats to the gateway router directly. So, I mean, we will have to work with your IT to open up some specific ports that the router is using to communicate on the existing firewall for it to sort of for enabling communication outside the facility. But we work, I mean, our implementation team, our experts are doing this, and they'll work with their IT team to identify those ports, open them up so that the communication is secure. And then, of course, we will continue to use other security protocols such as DICOM TLS to ensure that the data is protected while in transit.
Yeah, excellent. I see one more. Can this be hosted? I'm assuming you're meaning on maybe on a virtual server farm in a VM or in the cloud, and the answer is yes to all the above.
Yep.
Maybe Shreyas could expand, but yeah, that's no problem. We have customers doing that.
Yeah, absolutely. I mean, it can be hosted. It is something that we do quite regularly for a lot of our clients, multi-facility clients who want a gateway router on the cloud. So they'll have like a gateway router at each facility, and then one advanced maybe at the cloud that's automating a few more things that the basic standard one is not doing. And so we have all sorts of setup, but yes, it can definitely be hosted on the cloud.
Great. Well, I don't see any more questions. Thanks for helping me out there, Shreyas. All right, if we don't have any more questions, I want to thank everybody again for attending the webinar. We do have a brief survey after this. If you wouldn't mind completing it, we'd greatly appreciate it. So thank you again for attending, and this concludes our presentation.
Thanks, everyone.